Alright, let's go. Number 10. But before I tell you what might be inside every black hole in the universe, I need you to understand what a black hole actually is, because most people think they know, and most people are wrong. A black hole is not a hole. It is not empty. It is not a tunnel to somewhere else, at least not in the way movies suggest. A black hole is the opposite of empty. It is the most concentrated, most compressed, most extreme object that can exist in our universe. It is a region of space where gravity has become so strong that it has, quite literally, torn a hole in the rules of physics themselves. At the center of every black hole is something called a singularity. According to our best equations, this is a point of infinite density, infinite gravity, and zero size. Everything that has ever fallen into that black hole, every star it has ever consumed, every planet, every atom, every particle, is crushed down into this single mathematical point. And here is where it gets deeply disturbing. Our physics does not actually work at the singularity. The equations break down. They give infinite answers, which in physics means the same thing as no answer at all. We literally do not know what is at the center of a black hole. We have theories, we have possibilities, and each one is more horrifying than the last. There are right now hundreds of millions of black holes in our galaxy alone, trillions in the observable universe. And inside every single one of them, something is happening, something we cannot see, something we cannot detect, something the laws of nature refuse to let us understand. This is a list of what might be inside them. Not the boring answers, not the safe explanations, the real possibilities, the ones physicists whisper about at conferences after too many drinks. The ones that appear in serious research papers, but never make it into documentaries, because the implications are too unsettling. By the time we reach number 1, you will understand why some of the most respected minds in physics have said quietly that they hope we never find out what black holes really are. So let us begin. Number 10. The possibility that a black hole is a doorway to your own death, played on infinite repeat. Time behaves strangely near a black hole. As you approach the event horizon, the boundary beyond which nothing can escape, time itself slows down. Not for you, for someone watching from far away. From their perspective, you appear to slow down, redden, dim, and eventually freeze at the edge of the black hole. To an outside observer, you never actually cross the event horizon. You are locked there, forever. But from your perspective, you cross the boundary in an ordinary amount of time. You fall in, you experience whatever comes next. But here is the mathematical detail that scientists rarely emphasize when they explain this. The moment you cross the event horizon, according to general relativity, you are already dead. Not because something has killed you, but because the geometry of space and time inside a black hole is so distorted that the singularity at the center is no longer a place you are moving toward. It is a moment you are moving toward. It is in your future. Just like tomorrow morning is in your future. You cannot avoid your future. You cannot turn around and go back in time. Once you have crossed the event horizon, meeting the singularity is as inevitable as tomorrow arriving. It is not somewhere you can steer away from. It is when, and that when is coming, no matter what you do. Which raises an unsettling question. If the singularity is not a place, but a moment in time, and if time inside a black hole behaves in ways we do not fully understand, then what exactly happens when you reach it? Some interpretations of the mathematics suggest that time itself may loop, or repeat, or fold back on itself near a singularity. You may not simply die. You may die over and over in a compressed instant that lasts, from your perspective, forever. Every last thought, every last sensation, played on infinite repeat as time collapses in on itself. This is not confirmed. It is one interpretation, but it is one that emerges naturally from the mathematics, and it is one that physicists rarely discuss in public, because the implication is that inside every black hole, there may be a moment of death that never ends, and every star that has ever collapsed into a black hole, every civilization that ever fell in, every conscious being that ever crossed the event horizon, may still be experiencing that final moment, right now, forever. Number 9. The possibility that black holes contain entire universes. Here is one of the strangest ideas in modern physics, and it is one that has been proposed by respected researchers in serious peer-reviewed journals. Every black hole in our universe might contain, inside it, another entire universe. The theory works like this. When a massive star collapses into a black hole, the matter falling toward the center reaches such extreme density that our current physics simply stops describing what happens next. But some models of quantum gravity suggest that instead of forming an infinite density singularity, the matter might rebound, bounce back, explode outward in a new expansion, not into our universe, but into a separate region of spacetime that is causally disconnected from ours. To us, on the outside, it still looks like a black hole, a dark, silent region where matter goes in and nothing comes out. But inside, past the event horizon, past the point where our physics can follow, there may be an entirely new universe expanding, its own Big Bang, its own galaxies forming perhaps, its own stars, planets, and potentially even its own conscious beings, none of whom would ever know that their entire universe exists inside a black hole in another cosmos. And here is where it becomes recursive and truly disturbing. If our universe contains black holes that give birth to new universes, then those new universes will also contain black holes, which will give birth to more universes, which will contain more black holes. On, forever, in an infinite tree of universes, nested inside universes, nested inside universes, which means our own universe might not be the original one. Our Big Bang might not have been the beginning of everything. Our entire cosmos might simply be what is inside a black hole in a larger universe, one level above ours, whose inhabitants have no idea we exist, and their universe might be inside a black hole in an even larger universe above them. Reality could be a tower of nested universes, extending infinitely upward and downward, with no true bottom and no true top. Somewhere out there, in some universe above ours, a star collapsed, and that collapse created everything you have ever known. Number 8. The possibility that inside black holes, information is being erased from existence. There is a principle in physics that has been considered unbreakable for over a century. It is called the conservation of information. It states that information, in the physical sense, cannot be created or destroyed. If you burn a book, the information in that book is technically still there, encoded in the smoke, the ash, the heat. You could never actually recover the book from the smoke, but in principle, if you knew the exact state of every particle involved, you could work backward and reconstruct the original. The information is conserved. This is not a philosophical claim. It is a mathematical requirement of quantum mechanics. Without it, physics does not work. Black holes appear to violate this principle. Violently. When something falls into a black hole, all information about it seems to be lost. The black hole itself is described by only 3 properties: its mass, its electric charge, and its spin. Nothing else. Everything else about what fell in, every detail, every arrangement of atoms, every subatomic quirk, is apparently gone, erased, as if it never existed. This is called the black hole information paradox, and it has terrified physicists for decades because it means one of 2 things must be true, and both possibilities are unsettling. Either information is being genuinely destroyed inside black holes, in which case one of the most fundamental laws of physics is wrong, and our understanding of the universe has a gaping hole in it. Or the information is not being destroyed. It is being hidden somewhere, encoded somewhere we cannot see, in a form we cannot detect. Some theorists have proposed that the information is stored on the surface of the event horizon itself, in a pattern of quantum fluctuations too subtle for us to read. Others have proposed it is smeared across the entire universe. Others have proposed it is transmitted, somehow, to another region of space-time, perhaps one of those interior universes we just discussed. But here is the disturbing implication that this rarely comes up in the popular explanations. If information is not being destroyed, then everything that has ever fallen into a black hole is still there, in some sense. Every star, every planet, every atom of every civilization that ever existed in a system whose fate was to fall into a black hole. All of it, stored, hidden, waiting, in a form of reality we cannot access, but that continues to exist, somewhere, in the dark. Every black hole is a museum of things that vanished from our universe, but did not vanish from existence. Number 7. The possibility that a black hole is a mouth and it is chewing. We usually imagine a black hole as a simple hole that things fall into. This is not quite accurate. Inside the event horizon, once you have crossed the boundary, gravity does not just pull you inward. It stretches you sideways in specific and horrifying ways that physicists have given a specific name. The name is Spaghettification. Here is what happens. As you fall toward the singularity, the gravity pulling on your feet is stronger than the gravity pulling on your head. This difference is called a tidal force. And near a black hole, especially a small one, that tidal force becomes so extreme that your body cannot survive it. You do not simply get crushed, you get stretched. Your feet are pulled downward faster than your head, your body elongates, and eventually, the tidal force exceeds the strength of the chemical bonds holding your cells together. You are torn apart, molecule by molecule, in a long, thin stream of matter falling toward the center. But here is what the diagrams do not usually show. Spaghettification does not just happen to bodies, it happens to everything. Every star that a black hole consumes is spaghettified before it is destroyed. Every planet, every particle, every piece of matter that has ever fallen into a black hole has been pulled apart in the same slow, methodical way. And the process is not instant. It takes time. From the perspective of the matter being stretched, there are moments, seconds, sometimes longer, of being torn apart while still, in some sense, existing. If any of that matter is a living organism when it falls in and around a very large black hole, that is entirely possible because the tidal forces are gentler for larger black holes, then that organism will be aware of what is happening to it for some period of time as it is destroyed. We do not know what happens inside a black hole, but we know that this process is happening right now inside every black hole that is actively feeding. Every supermassive black hole at the center of every galaxy, including ours, is slowly, silently pulling apart whatever matter drifts too close. In the darkness beyond every event horizon, matter is being disassembled, chewed, digested, and whatever consciousness might have been attached to that matter is, for at least some period of time, present for the process. Number 6, the possibility that black holes are portals to other regions of our own universe. If you take Einstein's equations of general relativity and solve them for a certain kind of black hole, one that is not simply mass but also has spin or charge, you get something strange. The equations do not describe a singularity where you get crushed. They describe a passageway, a tunnel, a connection from one region of space-time to another. These solutions are called Einstein-Rosen bridges. Popularly, they are called wormholes, and they emerge naturally from the mathematics of certain kinds of black holes. If a wormhole is real, and if it is stable, then falling into a black hole would not necessarily kill you. It would transport you. You would enter the black hole in one region of the universe and emerge from something called a white hole, the theoretical opposite of a black hole, somewhere else, perhaps thousands of light years away, perhaps in another galaxy, perhaps in a different time. Now, most physicists believe wormholes are not stable in practice. Even if they exist mathematically, they would collapse the moment anything tried to pass through them. But this is a belief based on assumptions we cannot fully verify. The mathematics allows for them, the equations describe them, and no experiment has ever ruled them out with absolute certainty, which means it is possible, however unlikely, that some black holes are not endings. They are doorways, and every black hole in the universe might, in principle, be an entrance to somewhere else, to a distant part of our own cosmos, to another galaxy, to a region of space far beyond anything humanity could ever reach through ordinary travel. The disturbing part is not the possibility itself. It is that we would have no way of knowing which black holes are doorways and which are simply death. From the outside, they look identical. Every black hole in the sky is either an execution chamber or an entrance to somewhere unknown, and we cannot tell the difference, and we cannot test the answer without falling in. Number 5, the possibility that time inside a black hole stops working the way you think. Everything we know about physics assumes that time is real, that it flows, that there is a past, a present, and a future. We treat time as one of the fundamental features of reality. Inside a black hole, that assumption stops being reliable. Here is what happens according to general relativity. As you approach a black hole, time slows down relative to observers outside. If you were to hover just above the event horizon, 1 second for you might correspond to years, decades, or centuries for the rest of the universe. Time is not universal. It is warped by gravity, and near a black hole, it is warped to extremes. But something even stranger happens once you cross the event horizon. In the mathematics of general relativity, the roles of time and space swap. Outside a black hole, space is the dimension you can move around in freely, and time is the dimension that only flows forward. Inside a black hole, this reverses. Time becomes something you can move through in different directions, and space, specifically the direction of the singularity, becomes the thing you cannot avoid moving toward. Let me say that again in plain terms. Inside a black hole, time and space swap identities. Your future is no longer a set of moments in time. It is a location in space. The singularity. Space itself flows the way time normally does, dragging everything toward the center, and time can, in some interpretations, be experienced in ways that would seem completely alien from the outside. Some physicists have proposed that inside black holes, causality itself may break down, effects may precede causes, events may happen in orders that make no sense to us, loops in time might become possible. The very structure that keeps the past distinct from the future, that keeps memory separate from anticipation, may simply cease to function inside a black hole. If any of this is right, then the interior of a black hole is not just a hostile environment. It is a place where the fundamental rules of reality no longer apply. Time is broken, space is broken, the distinction between them is gone, and whatever falls in enters not just a physical death, but a collapse of the concepts we use to describe reality itself. Number 4, The possibility that black holes are the source of dark matter. 27% of the universe is made of something invisible. We call it dark matter, but that name is a placeholder. We do not know what it actually is. We only know that it exists. We can measure its gravitational effects. We can see how it holds galaxies together, but we have never directly detected a single particle of it. It does not emit light. It does not absorb light. It does not interact with ordinary matter in any way we can detect, except through gravity. For decades, physicists have assumed that dark matter must be some new kind of particle, something we have not yet discovered, something that would show up eventually in a particle collider or a deep underground detector. Despite billions of dollars and thousands of experiments, no one has ever found it, which has led a growing number of researchers to propose an alternative. What if dark matter is not made of exotic new particles? What if dark matter is made of black holes, specifically small black holes? Black holes formed not from collapsing stars, but from density fluctuations in the very early universe, moments after the Big Bang. These would be called primordial black holes, and they would be nothing like the giants at the centers of galaxies. They could be the size of a mountain, or the size of a marble, or smaller. Some of them might weigh only a fraction of a gram. There could be trillions of them, spread throughout the universe. Enough of them, combined, to account for all the missing mass. Enough of them to be dark matter. And here is the disturbing implication. If this theory is correct, then dark matter is not a substance. It is a swarm, a vast invisible cloud of miniature black holes spread throughout every galaxy, drifting through space in numbers we cannot count. There would be some of them in our own solar system right now, some of them passing through the region near Earth, and we would have almost no way to detect a small black hole passing through us, unless we happen to be watching the exact right region of space at the exact right moment. Every black hole is a hunger, and if the primordial black hole theory is correct, the universe is not mostly matter and mostly light. It is mostly small, invisible, drifting hungers, trillions of them, filling the darkness, waiting for something to fall in. Number 3, the possibility that black holes are broadcasting information out of the universe. We touched briefly on the black hole information paradox earlier, but there is a specific version of the resolution that is genuinely disturbing, and it deserves its own item on this list. The physicist Stephen Hawking, one of the greatest minds of the 20th century, discovered in the 1970s that black holes are not entirely black. They emit a very faint radiation, now called Hawking radiation, which slowly causes them to lose mass over enormous timescales. A stellar mass black hole would take longer to evaporate than the entire current age of the universe. A supermassive black hole would take even longer, but eventually, given enough time, black holes evaporate, they radiate away, they disappear. The problem is what happens to the information they contained. If the Hawking radiation is truly random, if it does not encode the details of what fell in, then all the information those things carried is lost when the black hole finally evaporates, which would violate one of the deepest laws of physics. The resolution that most physicists now favor is that the Hawking radiation is not random. It contains information. Encoded subtly in the pattern of the emitted particles is a record of everything that has ever fallen into that black hole. Every star, every planet, every atom, every possible detail of every event that has ever occurred inside that black hole's history, which means, if this is correct, that black holes are not just eating things, they are broadcasting. Every black hole in the universe is, at a rate too faint for us to currently decode, sending out into space a stream of encoded information about everything it has ever consumed. That information is going somewhere. It is traveling outward, at the speed of light, in the form of Hawking radiation, and if we ever developed the technology to read it, we could, in principle, reconstruct everything that black hole had ever swallowed. Which raises a question that most people never think to ask. If black holes are transmitters, then someone, somewhere, at some point in the future, might learn to receive their signals, might learn to read the pattern, might, in effect, recover the identities and structures of everything that has ever been destroyed by every black hole in the universe. The dead are not silent. They are just being broadcast on a frequency we cannot yet hear. Number 2, the possibility that black holes create new physics that we can never observe. Everything we know about the laws of nature is based on observations we can make, experiments we can perform, consequences we can measure. If a phenomenon does not interact with us, we cannot study it. Inside a black hole, this may not just be a practical limitation, it may be a fundamental one. The event horizon of a black hole is a one-way membrane. Nothing can escape from inside it, no light, no matter, no information. which means, in a very real sense, that whatever happens inside a black hole is causally disconnected from us. It cannot reach us. It cannot influence our region of the universe. It might as well not exist from our perspective. But here is the disturbing implication. It does exist. From the perspective of anything that fell in, the interior is real. The physics there is real. Whatever happens, there happens. And if the physics inside a black hole is different from the physics outside, if the laws of nature are different past the event horizon, we would never know. Some theorists have proposed exactly this, that inside every black hole, the laws of physics may be different, perhaps subtly different, perhaps radically different, different fundamental constants, different rules for how particles interact, different dimensions of space, different flows of time, an entirely different set of physical laws playing out in a region we can never access, according to rules we can never verify, which means the universe we know, the universe we describe with our equations, may not be the whole universe. It may only be the small, quiet, outside layer of a much stranger reality, and every black hole in the sky may be a window into a different set of physical laws, hidden forever from view. This is not a hopeful thought. It suggests that our science, no matter how far we advance it, will always be incomplete. There will always be regions of reality where the rules are different, where the physics is unknown, and where we can never send an instrument to check. The universe has kept and will always keep some of its secrets, sealed inside billions of black holes, protected by the geometry of space-time itself. Number 1, the possibility that we are already inside one. Everything we have discussed so far has been about black holes as things out there, objects in the universe that we can point telescopes at, that we can study from a safe distance, that we can theorize about. But there is a final possibility, and it is the one that keeps some of the most serious cosmologists in the world quietly awake at night, and it is this. What if we are already inside a black hole? What if our entire universe is the interior of one? The idea is called the black hole cosmology hypothesis, and it is not fringe science. It has been proposed in respected journals by respected physicists. The mathematics is not crazy. It works out. Here is the logic. When you calculate the size, mass, and density of our observable universe and compare those numbers to what the size, mass, and density of a black hole event horizon would be for the same mass, the numbers match. Almost exactly. Our observable universe has, statistically, all the properties you would expect of the interior of an extremely large black hole. Additionally, cosmology tells us that our universe began with a singularity, the Big Bang, a point of infinite density, infinite gravity, from which all of space and time expanded outward. Black holes contain singularities, and in the mathematics of certain types of black hole models, matter falling toward the singularity might, under specific conditions, bounce and expand into a new region of space-time, a universe, an expansion, a Big Bang, which means our universe might not have started as a random burst of existence in an otherwise empty void. It might have started as the collapse of a star, or the merger of black holes, or the formation of a supermassive singularity in a parent universe, a universe above ours, a universe whose inhabitants, if there are any, would look at what became our cosmos and see only a black hole, a dark spot in their sky, a region of space where matter went in and nothing ever came out, and they would have no idea that inside that darkness an entire universe was expanding, that galaxies were forming, that stars were igniting, that planets were assembling, that life was arising, that on one of those planets a person was watching a video about black holes, wondering what might be inside them, never suspecting that the answer includes themselves. If this is correct, then every star you have ever seen, every planet you have ever walked on, every person you have ever loved, every moment of your life, everything that exists in our universe, from the smallest particle to the most distant galaxy, is happening inside the event horizon of a black hole in a larger cosmos above ours. We are, all of us, inside. We were born inside. We will die inside. We will never leave, because the walls of our reality are not just the edges of the observable universe. They are an event horizon, and nothing crosses back. Every black hole in our sky, in this interpretation, is not an object separate from us. It is a mirror, a smaller version of the thing we are already inside. And every time we look at a black hole and try to imagine what it contains, we are, without knowing it, looking at ourselves. And that senior astronomer some of you have asked me about, the one who allegedly said, off the record, that he wished we had never looked. When he said it, this was one of the possibilities he had in mind. That the more we understand black holes, the more we understand what we are. And once you follow the mathematics to its conclusion, once you understand what our universe truly is, you begin to understand why some of the people who have understood it best have said, in careful, quiet voices, that they wish they had never done the calculation. You cannot unsee what black holes might really be, and what they might really be is the walls of the room we have always been in. If this video shifted the way you see the darkness at the center of the universe, then you should know there are older ideas about black holes, older calculations that never made it into mainstream discussion. I made a video about those. It is on the screen right now. If this one kept you up, that one will keep you up longer. And if you want to be here the moment the next black hole discovery drops, hit subscribe, because our understanding of these things is not slowing down, it is accelerating, and what we find inside the darkness may be stranger than anything we are prepared to know. Alright, see you in the next one.